All right, if you have not done the Explore activity on the first page, please pause this video and complete it. If you need more instructions, back up to the last video and see what I mean as I do this example on the Explore activity. But please, please, please do this first. So hopefully pause me, or you have already completed this. So if you have already completed the Explore, let's talk about what happened here. So on the next page, we have a table. On 1 and 2, we had some vertical shifts. You're going to have vertical shifts whenever you have a function and either a constant is being added or subtracted to the end. When you have a function and then you're adding a number, it's going to shift up k units. Or if you have a function and you subtract k, then it's going to shift down k units. This is Explore 1 and Explore 2. So I've had some trouble, to be honest with you, just being transparent, explaining this lesson and what this is kind of referring to. So let me do some examples here. What I mean by the f of x plus k and minus k is this right here. Whatever that function is, so in this one we have an x squared function, in this we have an absolute value of x function, and here we have a square root function. If you remember from last lesson, what I'm kind of talking about here are these different types of functions that we have. So if you take one of these functions, and these aren't all the functions, but if you take one of these functions here and you add a number to the back of this, that's what's going to make it shift up or down. So here I have x squared, which is a parabola, plus 3, so it makes this parabola shift up 3 units. Here I have the absolute value of x minus 5, so I'm taking the absolute value of x, which is that V shape, and I'm shifting it down 5 units. Here we have the square root of x function plus 10. Your square root function is that, I call it an eyebrow function. It like starts here and it just kind of slowly goes up. You're going to take that eyebrow function, you're going to shift it up 10 units. So you're taking whatever your function is and either shifting it up or down, depending if you're adding or subtracting something to the back of that function. Okay, so this is what I mean, and this is some examples of f of x plus and minus k. Okay, on 3 and 4 of the Explorer, you should have had some horizontal shifts. Horizontal shifts is when you add or subtract an h in the middle of that function. Now you have to kind of think of these as moving opposite ways. So when I have f of x plus h, we think of going positive to the right, but it actually shifts it to the left h units. When you have f of x minus h, we think minus goes to the left, but this actually shifts it to the right h units. So some examples of this are right here. I've got x plus 3 quantity squared. Because this plus 3 is part of this function, is part of x squared, it now moves this to the left 3 units. I have the absolute value of x minus 5, because this minus 5 is inside this function, right? Inside these bars, it's moving it to the right 5 units. The absolute value of x plus 10, because it is under that radical, because it's part of that function, that square root, it is going to take that eyebrow and it's going to shift it 10 units to the left. Do you guys see the difference between these two? Because I think this is where the majority of the confusion comes from. These have numbers being added or subtracted behind the function. These right here have things being added or subtracted as part of the function. You can tell the difference because these are kind of grouped, right? You have x plus 3, all quantity squared. You've got the absolute value of x plus 5. All of that's in that absolute value. You've got x plus 10, all part of that square root. So these are getting shifted left and right. This was left, this was right, this was left, while these are being added and subtracted to the back of your functions. So this went up, this went down, and this went back up. Okay, so that's what I mean by f of x plus k versus f of in parentheses x plus h. On the Explore activity, numbers 5 and 6 had to do with vertical stretches and compresses. Okay, when you are vertically shifting or vertically stretching or compressing, a lot of times we will use fatter and skinnier, and that's not really the case. Bad planning on my part, but I meant to have a demonstration ready for you. That didn't happen. But it's not getting fatter and skinnier. It's getting smushed together, compressed, or it's getting stretched out, but the width of it does not change. This happens when you multiply the function by a number. So if a is greater than 1, or in other words, well, no, I'm not going to say, I was going to say something, but that would have been wrong. So if a is greater than 1, it's going to get stretched. If a is between 0 and 1, so like 1/5, 1/2, 1/3, 7/8, if it's between 0 and 1, then it's going to get compressed. Some examples of that would be right here. 3 and 5 are bigger than 1, so those are getting stretched, but 1/10 times the square root of x, that's going to get compressed. And then lastly, on the Explore activity, 7 and 8 had to do with reflection. When you have a negative in front of your function, you are going to reflect it across the x-axis. But when you are having a negative inside of your function, you are reflecting it across the y-axis. This is very similar to your vertical shifts versus your horizontal shifts. Is it at the end of your function, or is it in your function? This is it before your function, or is it in your function? So some examples of this are right here. You've got reflected across the x-axis when the negative is in front of the function. So negative x squared, negative square root, or negative absolute value of x, negative square root x. It's reflecting across the y-axis when it is inside of your function. So parentheses, negative x, now squared, where that negative is part of your function. It's inside. The absolute value of negative x, it's inside your absolute value. The square root of negative x, it is inside of your square root function.